Alright, today we will be trying to answer the question, can birds predict typhoons? So there's this bird called a veery, which is a type of thrush related to the robins you may be more familiar with. Each year, these birds migrate south from their breeding grounds in the northern parts of the United States and Canada down to Brazil. This autumnal migration period occurs from the end of August through the beginning of October, which is also during peak hurricane season on the East Coast. When researchers compared the Veery's migration patterns with previous hurricanes, they found that in 3 of the last 4 Atlantic hurricane seasons, Veeries have been just as accurate, and in one case, more accurate than meteorological models. The exact science as to how they predict the future is still a gray area, but researchers have suggested that perhaps they can quantify how much precipitation falls while wintering in South America to gauge when hurricanes form to avoid them during migration. Nevertheless, if birds can help predict catastrophic weather events, preventive measures can be prepared in advance to protect human life and critical infrastructure. Therefore, I wanted to see if birds on the East Asian Australasian flyway could predict typhoons in the western Pacific. In this case, birds on this route breed in northeastern Russia by Alaska, fly along the Yellow Sea, along China's east and South Korea's west coasts, and finally reach their wintering grounds in Australia. It is somewhat ironic to call them wintering grounds because the seasons are flipped in the southern hemisphere, but it is the typical terminology used for migratory birds. Also, this flyway is home to a third of the human population, so not only are many of the bird species in decline from habitat loss, but it is at the most risk of catastrophic weather events like cyclones. In my study, I specifically focused on Typhoon Lakima, which incurred $15 billion in damages, killed 73 people in China and Taiwan, destroyed 149,000 homes, and demolished over 4,000 square miles of farmland. So, eBird is one of the world's largest biodiversity-related science projects, where birdwatchers from around the world can submit their observations to a public dataset that is professionally checked and utilized in ornithological research. I then chose 3 species of birds that are specialized to the East Asian Australasian flyway, meaning that they do not use alternate routes of migration. Since these birds have to fuel up and rest on the mudflats of the Yellow Sea, they would have to inevitably face the effects of Typhoon Lakima, which conflicted with their migration period in 2019 from August 3rd to August 14th. I also ensured that the 3 chosen birds had plenty of observations and were relatively distinguishable from similar species. I've provided this example comparing 3 species of snipe that all use the East Asian Australasian flyway. I honestly cannot tell you the visual differences between these birds even on close inspection, and since eBird doesn't necessarily require photos with every observation, I made the decision to not investigate any of these species. The species that I chose were the gray-tailed tattler, the far eastern curlew, and the great knot. The blue on the map is where they winter, and the orangish red is where they breed. All 3 of these birds are part of the sandpiper family, or Scolopacidae, and have similar habits. They all feed on a mix of crustaceans, mollusks, and snails along bodies of salt water. After the female sandpipers lay their eggs, they migrate south first, leaving the males to protect the young during maturation and migration. In addition, sandpiper chicks are precocial, meaning they can walk and feed themselves right when they hatch. In order to investigate the effects of Typhoon Lakima on migration, I needed a reference year. The problem is that July and August have the highest average number of tropical cyclones, as seen from the bottom row of this chart. By the way, cyclones, typhoons, and hurricanes all describe the same weather phenomenon, just in different parts of the world, so I will use cyclone and typhoon interchangeably. The reference year I chose was 2021, because the number of cyclones that occurred in July and August were below average. In addition, none of the 7 that took place were as destructive as Lakima, therefore the migration patterns in 2021 should be able to serve as a reference point. So I manually plotted each eBird observation from July 26 to August 26 in the years 2019 and 2021. as seen here. Oh, the bigger the dots, the more individuals that were seen in a single observation. Red dots indicate observations that reported 10 to 100 times more than the orange dots. So this red dot you see here in Malaysia represents 130 individuals. Okay, so first I'll just play through the video before I further explain the trends I found, but generally what you should look for are the red dots and the days in which one side has red dots and the other does not. Okay, here we go. Okay, did you notice any similarities or differences? Initially, I didn't either. So first, I noted the days that had red dots, which represent the major points of migration. Also remember that migration occurs in the sky when the birds are flying and you can't see them. So when observations are made on the ground, as the dots represent, the birds are actually fueling up and resting. So then I isolated these major stopover days in which at least two species had in common. The reason I did this was because the reality is that every species will exhibit a somewhat unique schedule for migration. However, Typhoon Lakima is not unique to one species and should be treated as a common factor. What I immediately noticed was that birds rested more days in 2019 than in 2021. But August 4th is somewhat of an extra rest day that occurs between the general period of July 30th and August 12th, or in 2019, July 28th and August 15th. After I conducted this preliminary comparison, I began closely spotting the differences between each of the species maps in 2019 and 2021. From July 28th to July 30th, I noticed these massive fluxes of gray-tailed tattlers and far eastern curlews in 2019 that are non-existent in 2021. As we move into the beginning of August, I noticed that more tattlers and curlews were resting on the Yellow Sea mudflats in 2019 than they were in 2021. Interestingly, on August 6th, more great knots were resting on the Yellow Sea mudflats in 2021 than in 2019. By making these objective observations, I was able to interpret a few trends. First, gray-tailed tattlers were less affected by the typhoon because their migration behaviors remained more consistent. Take a look at August 18th. The numbers of the gray-tailed tattler on the left side and the right side are about the same, and the same goes for August 22nd. You see these similar sized dots around China and Taiwan. Next, the far eastern curlews headed south before the typhoon hit. Those that encountered the typhoon on August 11th diverted west to China rather than east to their usual stopover sites in South Korea. Like the gray-tailed tattlers, many migrated earlier, thousands reaching their wintering grounds in Australia at the end of July in 2019. Take a look at July 28th through July 30th once again. On the left side, you have bigger stopovers in China and South Korea. A huge number of tattlers have already reached Australia by July 29th in 2019. The curlews reached South Korea by July 28th and reach Australia by August 4th, which is when Typhoon Lakima is still in its infancy at 35 miles per hour. On August 11th, when Lakima intercepted land, the curlews were in China, not South Korea. However, look at 2021. The curlews overwhelmingly preferred South Korea. especially evident from August 14th, August 16th, August 22nd, and August 23rd. Finally, fewer great knots migrated south prior to the typhoon in 2019. The fluxes in 2021 were more balanced, whereas the fluxes in 2019 are greater in magnitude. It is not until August 7th, if we go back to July, it's not until August 7th that the first major observations of knot migration were made in 2019, as seen from this red dot. If we go back a few, you can see there aren't really any red dots in July compared to in 2021. There are already red dots in the early parts of July. Because fewer had arrived in wintering grounds before the typhoon in 2019, August 15th through August 24th saw huge numbers of knots arriving in Malaysia and Australia. So I'll cycle through that here. So you can see the size comparisons, 15th, 17th, 22nd, 23rd, and especially the 24th. Some considerations to make in making conclusions from eBird observations include a lack of data in Siberia, where the birds breed, the effects of climate change over time, and the undefined nuances of species preferences for when they like to migrate and how they migrate. For future work, I would recommend plotting more migration patterns compared to typhoon trajectories, adding more species for comparison, and manually banding birds to obtain more precise data. These are my sources, and thank you so much for your time.